Okay, let's start with a heading. Today should be the 5th. And this is L-LO2. That's L-L02. Alright, and today we're doing locus theorem 2. And let's check something. Okay, locus theorem 2. The locus of points at a fixed distance, the locus of points at a fixed distance d, so the distance is d, from a line, and we're going to call this line L, is a pair of parallel lines d distance from L on either side of L. Okay? And here's a picture of what it looks like. Go down 1, 2, 3, 4 lines. Okay? Make a line. I'm going to go from like the 2 to the 6. So this is our line. Put arrows on the end so that we know it's a line. This is the line, and this is line L, according to the wording that we used. So the set of points at a fixed distance D from a line L is a pair of parallel lines, d distance from L on either side of L. So 2 lines above L, I'm going to make a dashed line to represent the locus of points. And I'm going to also go the same distance below L and do the same thing. Okay, and put arrows on the end of these. And it says that, so we have 2 parallel lines, right, that are on either side of L, and the distance away from L is D. So this distance here is D, and this distance here is D. Okay? So let's see. I want you to consider I place a strip of tape on the classroom floor which forms a straight line. Okay? I give each of you a yardstick. And ask you to stand exactly 3 feet away from the line on the floor. Okay. Can you picture what will happen? Describe where you and all your classmates will be standing. Okay? So, let's think about this, right? I'm going down 3 lines and I'm making another line, let's say from here to here. It doesn't matter how long it is. Just don't make it too small or too big. That's the line that I put down on the middle of the floor, right? I place a strip of tape on the classroom floor. So let's pretend that's a strip of tape. And I put it in a straight line. I give each of you a yardstick and I ask you to stand exactly 3 feet away from the line on the floor. Okay? So let's pretend this is right here. This is Kira, okay? And she stands 3 feet from the line. She stands on this side of the line 3 feet away. Alright? Now let's say down here, whoop, I have Ivan. He stands 3 feet away from the line also, but on this side. And then let's say on this side, I have Shane. He stands here. And then say over here on this side, I have Dulce. Let's say then next to Dulce stands Valeria. Then let's say up here next to Shane stands Nick. And so on. Let's say up here stands Kevin. And down here stands Casey. Can you see what happens as I add more and more students that all stand 3 feet away from the line on both sides of the line? Do you see what forms? This is what the locus means, okay? When you're thinking about all of the points that are a certain distance away from a line, in this case all of the points are students. The more and more points I add, you see what will happen is that eventually you will have a line here. Okay? So the locus of points, a given distance from a line, is 2 parallel lines that distance away from that given line. Whatever the distance is, they say in the problem. In this one it was 3 feet, so all of the students that form the lines are 3 feet from the given line. 3 feet above it and 3 feet below it. 2 parallel lines is your locus. Okay? So let's write down a little summary of what that says. So here's what I'm going to do. I'm going to put answer, and if you run out of room, just go on to the back. You and your classmates will form 2 straight lines. on either side of the tape on the floor at a distance of 3 feet away from the tape. Okay. And let's go on to say that you and your classmates are the locus of points. So you and your classmates are the locus of points equally distant That means the word for equally distant is equidistant, which means the same distance from a given line. Which in this case was the tape on the floor. Okay. So that pretty much covers locus theorem 2. Now we just have to look at some example problems. All right. So let's see what I got. Okay. On the back, I'm going to do example 1. The locus of points at a given distance from a straight line is, really I prefer to indent that, from a straight line is, and then there's 3 choices. 1 is one straight line. 2 is a circle. 3 is 2 parallel lines. And 4 is 2 intersecting lines. The locus of points at a given distance from a straight line. So over here, now this is the theorem that we just did. Let's just draw another example of it. I'm going to draw a short little line here. This is like the tape on the floor in our problem, right? The locus of points at a given distance from that line is 2 parallel lines, 1 on each side of the given line. That's the locus theorem we just learned. All these points above it and below it that are the same distance, okay, that's the locus of points from a line. So it's 2 parallel lines. And you want to have that picture drawn. Okay? Let's see. Two, three, 4, 5. Okay, so that's enough for that page. Let's take out a sheet of our graph paper now. Put our heading at the top. And this is L, LO2 still. And now we're on example 2. And it's what is the equation of the locus of points five units away from the y-axis. Five units away from the y-axis. Okay, so down the middle of my page, about in the middle, I'm going to draw I'm going to go down one line, and then I'm going to start my y-axis, and I'm going to go 12 total boxes, 6 above the origin and 6 below it. So 1, 2, 3, 4, 5, 6. That's my origin. 1, 2, 3, 4, 5, 6. This is my y-axis. And now I'm also going to go 6 boxes on both sides of that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's my x-axis. So, what is the equation of the locus of points 5 units away from the y-axis? Well, here's my y-axis. It's a line. So 5 units away would go 5 to the right. 1, 2, 3, 4, 5. And there would be a line there, right? Because all the points that are on this line are 5 units from the y-axis, but I can also go to the left. 1, 2, 3, 4, 5. And all of the points on this line are also 5 units from the y-axis, right? These two lines are parallel, and they're both 5 units away from the y-axis. These are the locus of points 5 units away from the y-axis, all the points that lie on these two lines. So they want to know the equations of these two lines. Well, the equation of this line is x equals 5. Okay, because it goes through the x-axis at 5. Just think about it. Every point on this line has an x-coordinate of 5. So similarly, every point on this line has an x-coordinate of negative 5. So this is the line x equals negative 5. So to answer my question, what is the equation of the locus of points 5 units away from the y-axis? The answer is going to be x equals 5 and x equals negative 5. Okay? And let's see if we can do another one on this sheet on the same thing. Describe the 2 units from the line y equals negative 1. Yes, so skip one line and let's put example 3. We should be able to fit this one. Describe the locus of points two units from the line y equals negative 1. Okay, so I'm going to draw the same. I'm going to even draw a smaller graph this time. It doesn't need to be that big. I'm just going to go 5. 1, 2, 3, 4, 5. Then I'm going to draw my origin. It's a dot. Then I'm going to go 5 below. 1, 2, 3, 4, 5. And I'm going to go 5 to the left and 5 to the right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the y-axis. This is the x-axis. So this is what I have, right? Describe the locus of points 2 units from the line y equals 1. First we have to draw the y equals negative 1. First we have to draw the line y equals negative 1. Remember this problem? Vertical lines are x equals. Horizontal lines are y equals. Y equals negative 1 goes through negative 1 on the y-axis. So this is the line y equals negative 1. Now I have to draw all the points 2 units from the line y equals negative 1. This is the line y equals negative 1. This point is 2 units away, right? 1, 2. This point, this point, this point, this point. All these points, even in between here, all of these points. So eventually, what does it form? It forms a line. And we usually draw the locus lines dashed so that we can tell the difference. So that's 1. And then we can also go 2 units down, right? Here, here, here. All along this line, 2 units away from that line. So we usually draw it in dashed, like I said. Those are the 2 lines. So this is the original. Don't get confused with the x-axis, right? This is the line y equals negative 1. And these 2 parallel lines are 2 units away from the line y equals negative 1. Okay? So if we were going to write that out in words, we would say the locus of points. I'm going to put this below it. The locus of points will be 2 lines parallel to the given line. Will be 2 lines parallel to the given line y equals negative 1 and at a distance of 2 units away from the line. But that's not it. We also want to write the equations of those lines. The equations of the lines are y equals 1, right? That's this top one here. This is y equals 1. It goes through 1 on the y-axis, and it's a horizontal line. Everywhere on this line, my y-coordinate is 1. And y equals negative 1, negative 2, negative 3. Y equals negative 3. Everywhere along this line, my y-coordinate is negative 3. So this is the line y equals negative 3. So our y equals 1 and y equals negative 3. Okay? So the problem says to describe, so a picture is not good enough. I need to also write out a description. That's how you describe something. You have to write out something. Okay? And that's it. So now we want to turn this over. And we want to do example 4. Okay. Here we go. Let me just see something. All right. So example 4. A straight driveway is 25 feet long. And 8 feet wide. Period. A gardener is planning to plant flowers . 6 feet from the center of the driveway. Describe where the flowers will be planted. Okay, so that's the problem. All right. So let's draw a picture of this situation. All right. So what I have is a driveway that's 25 feet long and 8 feet wide. Okay. So I'm going to move down just a little bit. And I'm going to draw a driveway looking thing, which is really like 2 straight lines. Okay. So this is our driveway. All right. And it's 25 feet long. So the distance from one end to the other is 25 feet long. And it's 8 feet wide. So I don't know if we really care about that. Let's just put here driveway. And if we want to show this is 8 feet wide. Okay. And this dimension is 25 feet. Now a gardener is planning to plant flowers 6 feet from the center of the driveway. Okay, so let's draw another line to represent. Now this is the center of the driveway, right? So this distance here is 4 feet, and this distance here is 4 feet. So he's going to plant flowers just outside of the driveway, right? 6 feet away would be 6 feet up, and also 6 feet down. So this is actually going to get in my way, so I'm going to erase that. We don't really need it anyway. And I'm going to make a dashed line. Now I'm going to pretend that this dashed line is 6 feet away from the middle of the driveway, but I can't just go below it, I also have to go above it. And we always make our locus lines dashed so that anybody grading this knows which lines we believe are the. So that's where the plants go. If this is the center line, 6 feet above it and 6 feet below it. So they go on the sides of the driveway, it makes sense, right? So now we have to write a description for that. Okay, so here we go. The flowers will be planted 2 feet from the edge of the driveway. Let's 2 feet. 2 feet, because it's 6 from the center, right? And we know this whole thing is 8. So the driveway is 4 feet and 4 feet from the center. An additional 2 feet on each side is where the flowers go, 6 feet away. So The flowers will be planted 2 feet from the edge of the driveway. Two feet from the edge of the driveway and on either side of the driveway. If the driveway is 8 feet wide, the distance from the center to either edge is 4 feet. Okay, so the 25 feet given in the problem, we actually don't need to write any more than that. That's it. Oh, we could put, no, we don't have to put anything. That's it. Okay? So let's move on to the next and last example. Okay, let's skip a line. Example 5. The locus of points equidistant from the line x equals 2 equidistant from the line x equals 2 and equidistant from the line y equals 1 must be graphed below. Put in x. Let's see. Put in x on all points that satisfy both conditions and state the number of points. Okay? So, let's draw our graph. I'm going to go this one. Whoop. We have to change this problem a little bit. The locus of points take out equidistant and put in 2 units and take out this equidistant and put in 1 unit. Okay? So locus of points 2 units from the line x equals 2 and 1 unit from the line y equals 1 must be graphed below. Put an x on all points that satisfy both conditions and state the number of points. So we need to first draw our graph. One, 2, 3, 4, 5, 6. I'm going to go 7 in each direction. 1, 2, 3, 4, 5, 6, 7. That should be big enough for this problem. 1, 2, 3, 4, 5, 6. Oops, 7. Okay. Y and x. So 2 units from the line x equals 2. So first let's draw the line x equals 2. That's this line. X equals 2. Now let's put the locus of points 2 units away. So that would be 2 units to the right. And 2 units from the left to the left, which would land right on top of the y-axis, and that's the line x equals 0. The y-axis is the line x equals 0. Now we also have to 1 unit from the line y equals 1. So here's the line y equals 1. And it's got to be 1 unit away, so I'm going to go 1 unit above. Make a dashed line, and I'm going to go 1 unit below, which is the x-axis this time. And the x-axis is the line y equals 0, and this is y equals 2. So here's 1x, here's an x, here's an x, and here's an x. So the important thing here is to make sure you only put x's where the dotted lines cross. In fact, dotted is not really that great of a word. We want to put dashed where the dashed lines cross. And then it says also state the number of points. 4 points. Okay? And that is the end of this lesson. So I had 2 pages. So what I have to do in the top corner of the first page is put 1 out of 2, and in the top corner of the second page I'm putting 2 out of 2. And that's the end of lesson 2 of locusts.